Let's do a problem from your lab assignment, section 11.3. This is number 1. Use the integral test to determine whether the series is convergent or divergent. So this is our series, the sum going when n goes from 1 to infinity of 10 divided by n to the 12th power. So in order to apply the integral test, the function on an interval must satisfy the following. F is continuous, differentiable, positive, negative, increasing, or decreasing. The statement of the integral test says that suppose f is a function that's continuous, positive, and decreasing on an interval 1 to infinity. Okay, so that's what we want. We want continuous, positive, and decreasing. So if that's the case, then we can use the integral test. So for our series, since f of x can be written now as 10 over x to the 12th, we're going to look at that as a continuous function. That function is positive, and that function is decreasing from 1 to infinity. So what we're going to do is we're going to take the integral of that, the integral from 1 to infinity. So remember that the integral changes into a limit as b goes off to infinity. And so I think in this step they want us to take the integral. So we think about this as x to the negative 12. If we add 1, it becomes negative 11. So we have a 10 times x to the negative 11 power, and then we have to divide by negative 11. Divide by the power. So this is essentially negative 10 divided by 11, and then times we have b, that's 1 over b to the 11th power. Now notice that the power is now positive because I put it down in the denominator, minus, and that's 1 divided by, and then we have to put 1 in, 1 to the 11th power. Now I can probably press submit here and get the correct answer because, well, I won't, because I need to let b go off to infinity. And so as b goes off to infinity, b to the 11th goes off to infinity, but 1 over b to the 11th would go to 0. So we can simplify this. The negative and the negative will become positive. We will have 10 in the numerator, and we have 11 times 1 to the 11th, which is equal to 1. So essentially we'll have 10 over 11 positive, because this negative 1 and this negative sign will cancel each other out. So your final answer should be 10 over 11. I'm just curious, yep, if we punch it in here, Mathematica will decipher and simplify all this to get the final answer. I encourage you to do this simplification and not submit your answer like I did here. All right, so now we get our result. Our integral converges to 10 over 11. So that means our series must also be convergent, because if the integral is convergent, then the series is convergent. Now there's one caveat here. The actual series sum is unknown. We can say that the series is approximately equal to 10 over 11, but we can't say what it is equal to exactly. So saying that something converges and finding where it converges to are two different things. And at this point we're going to be testing things now, series, for convergence or divergence, but unless it's a special series like the geometric series or telescoping sum, we won't be able to figure out where it converges to. All right, I hope that helps.